cluster manager of Luce in Veneto, the Italian cluster grouping SMEs on the smart lighting sector. Today, I opened this webinar with our expert, Anna Pellizzari from Materially, the consultant company from Milan, expert on use of new materials design. Anna Pellizzari, good morning. She will deepen out today the use of bio-based materials for durable and disposable application, including packaging and in the lighting and furniture industries. It's the topic today of the webinar. This webinar is part of the European project SILEO, of which Luce in Veneto is partner. That groups also other 6 clusters. So we are 7 clusters in this project that aims at enhancing the capability of the companies in terms of advanced technologies, new materials, Industry 4.0, and circular economy and digitalization. This is the topic and the goal of the project. The webinar is part of a cycle of a series of webinars that we started in November with the first 2 webinars that took place on 13 and 21 on life cycle of materials and recycling loop. And this is the 3rd meeting. We will have the last one on 30th of January on industrial waste management, in which we will deepen also the use of waste from different sectors, always with a focus in lighting and furniture ecosystem. That is the sector in which all the clusters operate in this project. So I remember you that all the webinars are registered, and so we can give you all the registrations and the slides if you need. We send you after the meeting all the materials, but if you don't have, please call us, write an email, and we send you all the materials. So I let the floor to our expert, Anna Pellizzari, and enjoy the webinar.
Hello, everybody. Apologies for my voice. Today I'm not in my best shape, but I will try and do my best anyway. So I start sharing my screen as usual. You should allow me to share my screen.
You are loaded.
Okay. 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 Hopefully you can see my screen properly. If not, just let me know.
Yes, it's okay.
Okay, great. So we are at the 3rd module of this, let's say, path on materials and sustainability. And the topic today is that of bio-based materials. We called this module BioFuture because we would like to give a general overview of what biomaterials are, and also providing some types of development, particularly in biopolymers. So as all the other modules, the course today is divided in 2 main parts. One is concerning general concepts, and the second, an overview on bio-based materials divided by their group. So when it comes to general concepts, what are bio-based materials? By bio-based materials, we consider a very vast family of materials. We will see a scheme right after these preliminary slides that would give you an overview of how many materials are bio-based and what are the possibilities of creating materials from basically renewable sources, from matter that has been living somehow. So basically, all bio-based materials are either materials, products, or even technologies and processes, manufacturing processes that are based on natural living cycles, both in the plant and also in the animal kingdom, and also in the world of microorganisms, which is a very interesting area where a lot of new startups and research centers are working. So these materials could be naturally occurring, like wood, for instance, or synthesized. So there may be some intervention by man-made processes. We will focus particularly on those materials that are retaking the area that plastic has occupied in the last 50 years. So the focus will be also on, particularly on plastic replacement, which is, let's say, an area where, especially in some sectors, there is a big interest in this type of developments. So generally speaking, okay, this is just an overview of the various types of bio-based materials. So we try to summarize them by grouping them into the origin of the raw material, which can be plant-based, algae and seaweeds, so marine plants, and animals like mammals, birds, fishes and crustaceans, insects, and also microorganisms, including bacteria, fungi, and phytoplankton. So clearly one of the broad areas is that of plants, which would lead to a various type of derivatives or let's say semi-finished raw materials, which goes from timber to processes, passing through cellulose, which is one of the most abundant raw material in the world. Fibers, starch and sugars, which are the base of most biopolymers. Oils is also a base for biopolymers, biocoatings, etc. Latex, that is basically a natural rubber that is used in an expanded format for padding materials for seats. Casein, which is a protein from milk. Calcium carbonate, that's also an interesting area where we will see some examples where natural calcium carbonate can be derived by shells, for instance, to replace minerals from quarries. Chitin, and then some processes that are activated by bacteria, fungi, and phytoplankton. What can we obtain out of these raw materials? Basically anything. So we would go from boards. Let's say the most basic bio-based material is wood, in the form of timber to make boards, to make furniture, to make doors, buildings, etc. Then paper, all different natural fibers that can be used for textiles, for composite materials, for padding, for carpeting, etc. Man-made fiber that can have bio-based origin, so via a synthetic process, a synthesis process that would convert some bio feedstock like sugars, oils, etc., into polymers, and then would be spun and translated into fabrics, composite materials, leathers, and also leather replacements. We will see some examples also of leather replacements that are partly or fully bio-based. The biopolymers, which is a very broad family, foams, padding materials, paints and coatings, biofuels, and also in the mineral area, bricks and tiles. So as you can see, we are talking about a very broad potential for bio-based materials. I would start the conversation with an open question. So if you can just answer in the chat. Why do you think that bio-based materials are interesting in your perspective? So you can also say that they are not interesting at all. But I would like to preliminarily understand what's your perspective on bio-based material, what you would expect, and what are the most interesting characteristics of bio-based materials in your opinion. So you can answer directly in the chat, and so I can read and comment your answers. Okay, well, we already have a lot of super interesting answers. Replacement of non-renewable raw materials, meaning that the natural bio-based materials are, let's say, renewable by definition. So they can be replaced in the natural cycle. Then because at the end of life, the CO2 from biomass do not contribute to climate change. Yes, absolutely. Bio-based and almost perfect model of circular economy based on sustainability. Interesting, a little bit generic. Reduce impact of the product. Yes, it can be, but it is not intrinsically true. So it can be, but it also may not be like that. That would also depend on the process. For instance, there are some materials that, like paper, for instance, which is not necessarily less impacting in terms of whole life cycle than plastic. That would depend on application. Biodegradability, not all. Yeah, in the very, very long term, bio-based materials are in general biodegradable, not all of them, or not that easily. But what comes from nature sounds more likely to be adapted to go back to nature. That's yes. And feels like something humanity has always been in contact with, so healthier. Yeah, I don't really agree on this. I mean, nature is not necessarily healthier. It's not necessarily better. Also, poison is natural, for instance. But yes, I understand the perspective. Reduce impact of the product. It can be, or it may be not, but generally speaking, yes, because bio-based material would act as carbon sink, would absorb carbon from the atmosphere somehow. So either they are balanced in terms of carbon footprint, or they even can work as carbon stock. Blah, blah, blah. Okay, super interesting. So I would summarize all the things that you've said. So renewable sources, bio-based materials, as you also have underlined, come from renewable sources which regenerate naturally, do not consume non-renewable fossil resources, clearly net of the cultivation and transformation phases, because nothing comes for free. We do not just pick up materials and use them as they are from nature. All materials, even bio-based, are always processed. So there is always the impact of the manufacturing process. Then carbon footprint. Bio-based materials belong to the natural carbon cycle and are therefore virtually carbon neutral, again, net of the energy used in their transformation. And then another interesting thing is that some biological growth processes require little or no energy supply, for instance, mycelium or bacteria. And that's an area where there are interesting developments. Then, if biodegradable or compostable, which is not always true, they can contribute to the reduction of the waste problem. This is particularly true for packaging, for disposable, because most materials, some materials that are claimed, for instance, to be compostable, maybe they also have a compostable certification. There are some leathers, for instance, that have a compostable certification, but no one would throw them in the compost bin, right? It's more a matter of not being harmful to the environment and having that certified by the compost certification. So some general concept. Bio-based. We've seen already, bio-based is defined as a material or raw material that comes in whole or in part, in which case we will speak of partially bio-based or bio-based content. It's always, as I also have underlined in the other modules, if you make researches on companies' websites, materials manufacturers' websites, you would see an overuse of the bio-based, eco, that type of wording. It is always important to check what's the percentage of bio-based. In some cases, it may be 30%, 20%. So that's something that should always be visible when a company claims its materials to be bio-based. I always, there is also the use of biomaterial in many cases, which in fact scientifically means a material that is biocompatible. So materials that would be able to used for implants or in contact with the human tissues like silicone or titanium, that type, that's a biomaterial, which is not bio-based in most cases. So the correct word would be bio-based materials or material with a bio-based content. Biodegradable. The term biodegradable indicates a material or a product that is capable of degradation due to the action of natural microorganisms in aerobic or anaerobic environment, and that should be specified, producing only carbon dioxide, methane, water, inorganic compounds, or biomass. The EBA, which is the European Bioplastic Association, and now we are talking about plastic, okay, recommends not to define a material as biodegradable without specifying the specific condition in terms of time and environment in which biodegradation will occur, and the related certification standard, which is in the case of plastic is ASTM, with some number for USA and EN for Europe. So biodegradable per se is a very vague definition, because a material may biodegrade in 10 years, others in 10 days, others in, so it's quite, it should be important when someone claims a material to be biodegradable to also define more the borders of that biodegradability, the conditions, and how long does it take to biodegrade, etc. Compostable is different. Compostability has a very specific standard in terms of temperature, time, because that's given by the industrial plant where compostability occurs. So the two types of compostability are, and the two main certifications are compost, OK compost, which refers to industrial composting, or home compost, OK home compost. And so in that case, we would talk about home compostability, and that would refer to home composting, small bins, I would say, and which is, of course, much more challenging because there is no specific set of humidity, of temperature, etc. So these are definitions that are normally given for packaging, so not for durable materials. But as I said before, there are some leather companies, for instance, that have certified their material as compostable, because that would certify that there is absolutely no metals, no harmful substances left in that hide. So it is more a certification of quality, I would say, rather than a certification that provides directions for end of life. So when it comes to end of life of bio-based materials, there is still the option of recycling, except for materials that are supposed to be maybe in contact with food and that type of things. In that case, composting clearly is the best option, because separation would be inefficient. These materials, if in contact with food, may also be dirty or damaged. Some compostable materials are designed to degrade very fast. So in that case, composting is the best option. In most other cases, recycling is still the best one. Then we have waste. When a bio-based material is incinerated, so waste to energy, can be a valid option for some materials. for instance, wood chips for wood processing waste. In many cases, many companies that work with wood would use their chips to heat as sort of energy source for their plants or for heating the offices, etc. And also in general, as also some of you commented before, even in case of incineration, the carbon that will be released in the environment in the process has been taken from the atmosphere in the first place. So in the end, we would have a carbon neutrality anyway. The other two options, which are landfill and littering, clearly those are gray because it's theoretically not an option. But the idea, for instance, of claiming a material to be biodegradable as if that would solve all end-of-life problems, I personally don't agree with that perspective, because all materials, even though bio-based, should be managed at the end of life. So even if a material is biodegradable, it may be even worse in a landfill, for instance. Some biodegradable or compostable materials, plastics particularly, they may rot, they may sort of release some methane, for instance, that would be left in the atmosphere. So there is no, let's say, relationship between being biodegradable and being automatically good. There should always be management of waste in any case, even for bio-based materials. And that's particularly true for littering. And particularly the European Bioplastic Association does not support any claims that advertise bioplastics or biodegradable plastics or even compostable plastic as a solution to the problems of littering. This is something that it has not always been like that, because I remember like 10, 15 years ago, advertisements of oxo-degradable films, bioplastics, that would show crisps bag left in the fields, in the wood, and that would biodegrade. And at that time, it felt something good to communicate. No, even if you litter, that littering would not be harmful to the environment, which is not true, and which is also something that is absolutely not recommended as a type of communication and as a way of promoting compostable materials. So after all these premise on general concepts concerning bio-based materials, oh, sorry, I forgot to update this slide. This should be with bio-based content. I will correct it before sharing the presentation with you. We will go to have an overview on different case studies and materials in the sectors that make sense for you. So let's start with wood and wood-based materials, including timber, derivatives like chipboards, MDF, plywood, other panels, and also other panels of plant-based origin. Of course, these are materials that are bio-based by their intrinsic nature. So there is not very much to say. They have a renewable content, of course, because wood is a renewable material. Clearly, the management of forestry should be kept into, should be the focus of these types of woods, but I'm not saying anything new in that. So clearly the focus on these materials would be more the responsible sourcing, the manufacturing process, etc. There are some interesting materials, for instance, in terms of raw material, that maybe that would replace bio-based raw materials, that would replace with bio-based raw materials the binders or other components with oil-based or fossil-based origin. Another perspective would be that of using materials from agricultural waste or materials that would be growing faster than trees, or capable of absorbing greater quantities of CO2, or with regenerative properties of the soils. So some examples here, especially when it comes to chipboard or MDF, which are basically recomposed woods. There is the need of a binder to keep the chips together. And there are several researches to find bio-based binders that would release, that would not contain urea formaldehyde as a component, and therefore would not release it in any moment of the process, and that would allow the material to be claimed 100% bio-based. This is a lignin-based binder. Lignin is a bio-based organic polymer that is contained in wood. Wood is basically made of cellulose and lignin. In this case, the wood comes from FSC or PEFC certified forests, and the company is 14001 certified. Another interesting area is that of veneers. And normally wood veneers would be sort of bleached, so decolored and then recolored, also to obtain some uniformity of production and the possibility of reorder exactly the same color. There are some companies that have developed
We have some problems with Anna Pellizzari.
particular colors. This is a German company, but for instance, also Listone Giordano and Margaritelli has...
Anna, sorry, can you please repeat the last 2 minutes, because there was a problem with your audio and video. Okay, sorry.
I'm sorry.
Maybe can start with this slide, yes.
Okay. I can maybe take off my video. Maybe if there is some...
No, it's okay with the video. But...
Okay. Yeah, I was saying that this is another interesting area is that of veneers. Normally, veneers are bleached, which means decolored, and then recolored in order to have a full control over the final hue and also a constancy in the quality, visual and also performance. There are some companies, including this one, that have developed some mineral salt-based
So Anna, I don't know if you can hear me. We have problems with your audio.
imitating.
Anna, we have some problems with your audio and video. So I ask Isabella and Kristen to stop the video. So we can.
Okay, can you hear me?
And also your Anna, if you can stop the video, only the slides.
Okay. Let me.
We try like that.
Okay. Okay. I removed also the earphones. Maybe that was also may give a problem. Or was it a problem of conversation, of connection?
We try like that.
Okay. If you still have problems, let me know. Okay.
Yes. Yes, Anna, you can go on.
Okay, thank you. Apologies for that. So let's explain again this naturally dyed veneers. They are basically veneers that instead of being bleached and recolored are dyed using natural salts that would interact with some, let's say, the natural chemicals that are in the wood structure, and that would activate a change in the color of wood. In some cases, simulating the aging, the change in color that naturally happens through aging of wood. Okay.
There's a question in the chat, Anna, if you want to reply or if you want to do that after.
Yeah, I read the answer. The question: is there in Italy materials tested using ASTM test method D6866? I don't know, honestly. I am not that expert in tests for all materials, but we can check. So basically, EN ISO equivalent of this ASTM. Okay.
You're asking to Federica? No, okay.
Yes, I'm asking to Federica whether she means that if she's looking for materials that are
Posso attivare l'audio di Federica io, sì.
Sì, sì.
I tried to open the audio. Okay. Hi, Federica.
Hi. This is for a question for LEED, because LEED is a sustainability protocol from US, and this is a test method from US for bio-based materials. This is why in LEED project we don't use or we don't have recognized bio-based materials, because this is a test method only from US, or I don't know if there is some materials in Italy that are which have the bio-based part is test method. So there is an alternative to this test method, there is some material using this test method. This is why my question.
Okay, so basically D6866 is a method to test the bio-based or certify the bio-based content of a material.
Yes, this is what I can.
And you are looking for materials that are materials in which any material or
construction
or
materials.
some specific sector?
Construction materials. General for buildings.
Okay. I didn't hear very properly. I don't know whether it's my problem again or, but I will try to answer separately. Okay, building cost. Okay, understood. Okay. I will try to answer after, right? After this presentation. Okay, so let's go on. So I was saying that in this group also there are some materials that could come from either agricultural waste or rapidly renewable materials, like in this case, which is a veneer that's basically a decoration surface that's basically created out of grass, flowers, and other types of surfaces, and that are kept together by a bio-based binder, and that works as a decoration surface. These materials comes from Austria and are manufactured in Austria and have the raw materials all come from Europe. And particularly also they retain the smell of the original raw material, like grass, for instance. This instead is another artistic way of exploiting the agricultural waste from corn. This is a project by a Mexican designer that used the different shades and hues from yellowish to reddish of corn to create this type of veneer and this type of decorative surfaces which exploit these natural contrasts and to create these types of decorations. This is also another material that uses as a raw material rattan from Indonesia. Rattan is a fast-growing material which absorbs a large quantity of CO2. In this case, the material it grows very fast and it's very fast renewable, which is also another characteristics that can be taken into account when considering bio-based materials. So it's not the same working with a material that took 40 years to grow or 40 weeks. In this case, the company basically exploits the capillarity of rattan and fills it with some glue and some binder in a very small percentage. Basically, we have 97.5 rattan plus 2.5 binder and coloring agents to make the material resistant and long-lasting. The material is then combined together, glued together to create these blocks, which can then be either used as they are, as blocks, or sliced into veneers, both vertically or perpendicularly, creating two different types of decorations, which could be stripes or dotted based on the line of cut. These veneers are used in furniture and in automotive. It can also, let's say, if the resin that is used to fill the holes, let's say the small holes of rattan, is transparent, and if cut, let's say, in the perpendicular direction, the material can also be translucent and also backlighted. And the second group of materials is papers and, okay, just to say, in terms of woods, clearly all other standard woods are bio-based. So we try to highlight in this case some, let's say, new or original or a little bit special solutions. We will be more focused on those materials that are less obviously bio-based, right? So papers and paper-based materials, just like wood, are obviously bio-based. So there is not much to say in this group, except that maybe some interesting papers could be those that use waste, incorporate some waste materials that could be bio-based or from other types of industries. Or papers that would use fibers from more rapidly renewable plants, or other than trees, or papers that would be given types of performances via particularly production processes or treatments, etc., that would make paper able to replace plastic somehow for some applications. And we've seen that particularly recently in packaging with the single-use plastic directives, single-use packaging, directives, and there are a lot of new developments in that direction. So an example is, well, there are several paper companies that propose papers with, let's say, fancy content. This is an example from Favini, but also Federigoni or Burgo or other. All of them have some type of a line that would incorporate types of waste from either from the food industry or from other types of cultivations or from algae, etc. In this case, we have wastes from hazelnut, almond, olive, kiwi, citrus, corn. They also made a project with the Barilla trying to incorporate some of their, I don't know the English word for that, but the husks maybe from wheat that of course is a very important byproduct of the flour industry. So it's a way of reusing some types of waste that would be otherwise either composted or incinerated or disposed in some way. As I was mentioning before, all the area of plastic replacement in packaging is very active in recent years. There are different clusters of companies that have gathered together. Three main projects are around the creations of paper-based bottles, This is Pulpex, but there is also Pabocco and another one, the name I don't remember. Basically, the idea is to create bottles that would be more easily recyclable because paper has a much more efficient supply chain when it comes to recycling. That would be biodegradable in the worst case scenario. And that would, in the end, have a lower carbon footprint than glass, particularly, but also of PET. In general, the area of paper pulp for packaging has already replaced a lot of different shells. For sure, you may have noticed that your cell phone has now paper shells in the packaging inside and no more plastic ones. You may even not have noticed it because the quality of these paper pulp shells is really high, and also the surface quality is very smooth, and it feels like plastic somehow, but it's actually still made of paper pulp. Another area is that of EPS replacement. These are some posts from Sonoco that would be used as packaging for heavy and bulky products like appliances or furniture, etc., to replace styrofoam, basically. They are very strong, lightweight, and again, very easily recyclable. And it also with the recycled content in this specific case. Paper with also very high quality are being produced. This is a quite durable paper and with a very precious touch, which is again used for packaging, and with the idea also of creating a packaging that is shoppers particularly, but not only, it can also be wraps or boxes or whatever, that would be later reused and to prolong the life of paper and not just be something that would be thrown away once you are home. The paper in this case is made, it's also slightly washable on the surface. Not, I mean, it's not fully waterproof, but it can be wiped a little bit. It is made by virgin fibers that are treated in a special way in order to have this very high quality surface. Other fancy applications of paper includes yarns. We have recently, we are collaborating on an exhibition that will take place in Domotex in January, and we have selected carpets made out of paper yarns, which are very unusual and unexpected. So paper can also be used in some cases for durable applications. You all know this material. Maybe it was also in the module 1 presentation. It's a board made of paper and bio-based binder. And this is also another interesting material. There are several that would use cellulose, pressed cellulose as a raw material to create durable products that could be used also for very durable applications. In this case, it can be corrugated or formed in ways to make it stiff and be used in hidden parts. So not in contact, direct contact with the exterior, but for structural hidden parts, they may be a good replacement for wood. Minerals, well, talking about bio-based minerals may sound weird, but there are some bio-based solutions. We have seen some also in the first module. There was engineered stone that would use a bio-based resin as a binder. But for instance, as I said, there could be some mineral materials that could incorporate some material with a bio origin. This is the case of this biocement or biomason. It is basically a process. The material per se is standard calcium carbonate, but the binding process, I would say, instead of being made out of use of temperature, so high temperature, it is made by using microorganisms and bacteria particularly. So this would be a process that would occur in environment temperature, so it would not require heat, and for this reason it is with a very low carbon footprint. The technology has been around for quite a few years, and it is now being taken by a Dutch company, which is Stone Cycling, if I'm not wrong. But what's interesting in this case is more the manufacturing process rather than raw materials. Then shells that have a natural content of calcium carbonate can be used as either a source of calcium carbonate or simply ground and incorporated into these slabs. This is again a Dutch company that would incorporate these raw shells from oyster shells from restaurants that would be ground coarsely and incorporated in mineral matrix with a binder again, and basically reducing the content of quarry-based minerals, and also resulting in some fancy surface, which is mostly used in restaurants, clearly, or in environment where this type of decoration makes sense. It's interesting because the mother of pearl effect of oysters would shimmer here and there, so it has also a nice visual, nice look and feel. Then a bio-based content may be combined with natural minerals to create bioplasters or coating. This is an Italian company that makes use of rice husks and straw and incorporates them into materials for bioarchitecture. These bio-based content have various functions. On one side, it regulates the humidity of the air. It would reduce again the need for quarry-based minerals. It would also give some insulating properties, higher insulating properties, and a nice texture, which is also something to be considered. It is a local material, and they work with the territory where rice is grown traditionally. So it is also a type of, let's say, local supply chain that would retrieve and reuse some agricultural waste that would again otherwise be would need to be disposed somehow. And we go to bioplastics. This is going to be a long chapter because also the word of bioplastics, just like the word of plastic, is really broad. Rice house, exactly. So I would normally not mention the companies, not to make a lesson, an advertisement out of this lesson, but if you are interested in some specific material, just ask. So bioplastics, we used the definition of bioplastics that is given by the European Bioplastics Association, which defines bioplastics as bio-based or biodegradable plastics, or both. Whereas bio-based, we've seen, means having a content that comes from renewable source of plant origin, also animal, but in the case of bioplastics, it would be 99.9% plant-based. Bioplastics are often used in compounds. They are compounded, very rarely they are pure one type of bioplastic. They would normally be compounded to combine the different performances and to create some materials that can be viable in an industrial environment, or in other cases to ensure biodegradability. So to balance the properties of different bioplastics to obtain certain kind of performances. The so-called oxo-biodegradable and other additive mediated plastics are not considered bioplastics. These are almost non-existing anymore. They were still around until a few years ago, and they are basically standard plastics that are with additive that would break the links among polymers in contact with either UV light or oxygen, and resulting basically in microplastics. So these are have been abandoned, slowly but firmly abandoned by the industry. So if we go back to the definition, we see here that bioplastic can be either bio-based or biodegradable or both, which means that bio-based doesn't imply biodegradability. So there can be bio-based materials that are biodegradable and oil-based materials that are biodegradable. When it comes to why bioplastics, why should one use bioplastics? Those that are compostable, clearly they find applications in disposable applications to replace traditional plastics. And here we have all the, let's say, new directions on single-use products that would require a conversation, but I will not go into that because we are not talking about disposables in these lessons. We are talking about durable products. But in this case, when we talk about compostables, normally the purpose is waste reduction. So composting some products that would be single use. While in the case of non-compostable, the main reason is the reduction of carbon footprint, which should be measured in order to provide a comparison, because it's not that obvious. The comparison between the carbon footprint of oil-based and bio-based has evolved through time. I remember like 20 years ago, it was not that obvious that a bio-based plastic would have a lower carbon footprint because of the transformation processes that were less efficient. So there has been an evolution in that, whereas today bio-based plastics are normally more efficient, so less impactful in terms of carbon footprint than oil-based ones. Another open question, just to make a short break, and also if you have some questions, it's been 1 hour now, so we can have a small break. What could be the problems related to the use of bio-based plastics in your perspective? Probably many of you has already approached this family of materials, and maybe they may have found some difficulties, or if not directly, maybe you can envision types of the negative aspects of bioplastics, which we are going to talk about in the next slides. But I would like to ask you first if you have any, if you can envision negative aspects of bioplastics. You can type your answer in the chat. Oops. Okay, they can end up creating microplastics and contaminating other plastics recycling streams. Yes, that's particularly for packaging, and for some types of let's say, compostable plastics that are proposed for packaging. There are some issues concerning the actual compostability and also the quality and the type of value or non-value they would give to the final compost. And we will talk about this later. Contaminating other plastics recycling stream, yes, that's another I would see these two aspects as different. One is the what happens after composting or biodegradation, in case the material is biodegradable or compostable. And another problem is the difficulty that the consumer has in recognizing these bioplastics and putting them in the right recycling stream. Cost, yes, absolutely. This is one of the main problem. Bioplastics are much more expensive than oil-based ones, and this is for not just for plastic but also for fuels. So that's an open thing. The energy that is necessary to create bioplastic is of the same magnitude of the energy needed to build fossil-based plastics. And then the problem of the competition with food. Yes, these are also other aspects. In some cases, it's even more in terms of energy used than that, but we would not have all the impacts of extraction. So the impact of extraction of oil is huge. And that would make the balance, even if clearly to create bioplastics, you still use most bioplastics are are not derived by waste or by agricultural byproducts, but by specific cultivations. So there can be an issue on arable land, and we will see that later. Lower mechanical property, that would depend on the type of bioplastics. There are some with low mechanical property, others that are exactly the same. So there is basically no difference. In some cases, yes, there is the LIGO example is interesting, that we've seen in probably the first module, or the second module when we were talking about recycling. LIGO have never, I mean, they tried some bio-based plastics, but just for small objects, not for the bricks, because those would not be efficient enough. Also, that's a special type of ABS they use to make it virtually indestructible. And yes, in terms of super specific performance, maybe bioplastics are not the right choice, but there is a broad variety of bioplastics where you can choose among. And yeah, it's again a big word. Confusion over disposal options can also be an issue. Yes, it's the Marta, the same thing that you contaminating other plastic recycling streams. Yes, because you dispose it in the wrong way. You know, you as a consumer may have difficulties in understanding where I'm supposed to put this. Right? I see a film. For me, a film is a film. A bag is a bag. It's transparent. It feels like plastic. I will put it in the plastic. But yeah, that's okay. So super interesting contribution. Thank you very much. And we will go through some critical issues. So the first critical issue is the definition. Okay. As we have seen, bioplastic, the word bioplastics include both bio-based and biodegradable, which, as we will see, are two different things. Then the directive on single-use products has introduced another definition of plastic that is extended to most bioplastics. So according to the SUPD, they would consider plastics also most bioplastics, with some exceptions. So it's really a messy area. Then there is the feedstock. Some raw materials, for instance, corn, can interfere with the food chain, as someone said. I would say that normally bioplastics are not made of materials of raw feedstock that is edible. That's not the problem. The problem is more with arable land. So the land is that. We cannot have another planet to grow materials to be used as a biosource for other materials. So that's mostly the issue, and we will see later something on that, some information on that side. And then end of life, as many of you underlined, not all bioplastics follow the same path when it comes to end of life management. Some bioplastics can be recycled, other can be composted. Most ends up in landfill anyway, or incineration. And besides, even certified compostable bioplastics have been found difficult to decompose in composting plants, and they may release microplastics. So you have already give a good, I just summarized in this slide all your comments. So when it comes to feedstock, there is a debate over where these bioplastic come from. I would say that most bioplastics today still come from agricultural feedstock. We would define food crops, but they are actually the corn that's used to make bioplastic is not edible, is a special type of corn that has been in most cases engineered to be more efficient, to create starch to make bioplastics. Other are totally non-food crops like palm oil, palm kernel oil mostly, castor oil, rapeseed oil. But these still are agricultural, okay? So they would compete somehow with the same land. They may not interfere with the price of the material, but they would eventually interfere with the price in the way that some land may, companies may prefer to grow feedstock to make biofuels, for instance, other than food, because that would be more, that would give an economical advantage. The second type of, the second generation feedstock is defined as non-agricultural plant-based feedstocks, like wood, for instance, wood chips typically. And this is still difficult, I would say. Agricultural waste, so byproducts. So in the case of sugarcane, for instance, all the molasses or bagasse, so the materials that come out of the refining process that would be give access to food. That type of waste can be used to make bioplastics. And used oils, that's an interesting area where the used cooking oil can be used to make polymers, to make either biofuels or bioplastics. And then there is the third generation feedstock, that's algae or organic waste by fermentation, and this is very much under development. So first and second are already there, third not yet. There is some companies, but not in a, let's say, broad. Okay, Arab competition on arable land. These are the okay, these are data coming from the European Bioplastics Association, so it's let's say partisan, but data is data. At the moment, most arable land is occupied by pasture for animal breeding. Then there is food and feed, material use, meaning like wood, that type of use. Bioplastics is still really, really tiny, while biofuels is quite important. And that's basically Brazil. So this chart can give you an idea of where the problem really is in arable land. At the moment, not on bioplastic. So which types of bioplastics are there? There are virtually any type of polymer can be produced using a renewable source, a bio-based source. In general, just to be very, let's say, coarse, we can divide them into technical, commodity, and compostable. Compostable are used for disposables, mainly for packaging and agricultural applications. Commodity for any type of application. And then there are also some, let's say, more specialty biopolymers, which are basically the bio version of standard polyamides, TPE, polycarbonate, and PMMA. and those would be used for performance products. These are the most expensive normally. As I said, not all bio-based plastics are biodegradable, and not all oil-based plastic are not biodegradable. So in this chart, we have tried to summarize again, we do not expect it to be 100% complete, but to summarize the different types of bioplastics, which are the blue and the green ones. The gray are traditional plastics, which are oil-based and non-biodegradable. So the quadrant low right. On top, we have bio-based, which can be either biodegradable or non-biodegradable. So all bio-based PE, polyamides, polypropylene, PC, etc., or partially bio-based PET, TPE, PU, etc. And those are not biodegradable, although they are bio-based, and so they are called bioplastics. Then we have oil-based polymers like PBAT, PBS, EVO, that are normally used for packaging or for like barrier packaging, so providing, and that are biodegradable, and then oxidegradable. I put them there anyway, but still they should not be considered in any way. And then on top left, we have bioplastics that are both bio-based and biodegradable. And again, those are mostly used for either in compounds or for disposable applications. PHA, and we will then go through all these types of polymers also to check their level of performance. We will focus, of course, only on bioplastics for durable applications. We didn't consider in this presentation all those very fast compostable plastics that are mostly designed for packaging and for disposables. We have listed some the sustainability focus that concern the content and the sourcing, the production process, the global warming potential that is lower than standard plastics, mostly due to the extraction weight of standard plastics. It raises some controversy as third generation feedstock is still a minority. And then there is some competition on arable land and deforestation. And then biodegradability, as we said before, claims potentially labeled as greenwashing, because biodegradability, okay, but still all plastics and all material should be disposed in the correct way at the end of life. So biodegradability per se, it's not necessarily good. When it comes to material trends, there is a direction to work on mass balance bio-based, to have a chain of custody for the feedstock, so to know exactly where that feedstock comes from. And that's it. So if we go if we make a very quick overview on all types of bioplastic for durable, PLA is normally not very durable, but it can be combined with some fillers. In this case, this is a Finnish startup that had launched this compound of PLA with medical grade and therefore virtually compostable fiberglass, which would create a material that is very stiff and also quite resistant to temperature. And so let's say a type of PLA compound with very good technical performances. And then we have PHA, PHB, polyhydroxyalkanoate or polyhydroxybutyrate. Again, these are plastics obtained from bacterial fermentations of sugars normally. They are often used in compounds with other bioplastics. They are more resistant, more durable than PLA. They have a higher melting point, so they would be more resistant to temperature and to humidity, and would degrade less fast. And in some cases, they may also be machine washable. No, not in washing machine, but in dishwasher, sorry. Although maybe the color may fade away, but yeah, we started from the less durable and we are going to the more durable. Then we have lignin-based thermoplastics. There are two main companies working with lignin. One is German and one is British. Lignin is always used as a part of a compound because per se it has difficulties in processing, but it has interesting properties, and it may give also plastics some type of woodish look and feel. In this case, we've seen some applications in heels. These are like small batches of different compounds where lignin is combined with other bioplastics, with wood fillers, and we are talking here more about biocompounds rather than purely bioplastics. Lignin is also used as a binder as alternative to urea formaldehyde resins for some HPL. So it is an interesting material, I would say. It's super abundant. It comes from wood, so it's yeah, interesting. Then we have cellulosic resins. Again, this is a family of bioplastics. The most let's say known is cellulose acetate, used for eyewear frames, also for packaging. It is obtained by chemical modification of cellulose, which is a natural polymer that is super common in nature. And they can also be used to produce accessories or spun into fibers like viscose, modal. We will see those later. Although by their nature they are biodegradable, it may have happened to you to leave cellulose acetate frames somewhere in a drawer, for instance, for years, and then noticing that it has been damaged by time, basically by humidity, by oxygen, etc. But the biodegradation varies, so it would depend very much according to the composition of where you would store the material. But let's say theoretically they are biodegradable. Then we have bio-based materials that are not biodegradable. The most famous is the green PE. It is broadly used in packaging, again, typically in a certain percentage, or it can be compounded with other material. It is supple as all. It's, let's say, typically low density grades, so not very much used in very durable applications. But this is basically the same as standard PE. So when we come back to the problem of combining of disposing of this PE can be recycled exactly with the same as other PE. So it is virtually undistinguishable unless you make carbon-14 analysis of the material. Otherwise, the material is exactly the same as the other polyethylene, and it can be recycled together. Then we have bio-based durable polymers, typically polyamides or TPE or blends from plant-based oils, from castor oil, palm kernel oils, and other plant-based oils. And these are, again, completely durable, non-biodegradable, more resistant than cellulose acetate, and available and used also for very, let's say, demanding applications like eyewear frames, even ski boots. So with also a very good temperature resistance from very hot to very cold. So high-performing bio-based polymers. And then we have bio-based polymers with mass balance attribution. We have seen the mass balance concept last time when we were talking about recycling. It's the same concept, but using bio-based feedstock. So the attribution is given in percentage according to the quantity of bio-based feedstock that has been used in the cracker, basically. In this case, we have exactly the same material. In terms of performance, it doesn't change anything. At the moment, there is a low availability of bio-based polymers with mass balance attribution, low availability, high price. But let's say in the future, that could be an interesting option, not to trade off with performance. When it comes to foams, there are partially bio-based foams available, typically the polyols in expanded polyurethanes in blocks. The polyol part can be bio-based. Also, in this case, clearly the price is higher, not super higher, because there is quite broad, it's a commodity material, the broad number of polyurethane manufacturers provide this type of solutions. So there is also some type of competition. It's commonplace material. And in that case, you will have a partly bio-based content, and that would work for the carbon footprint of the material, basically. Otherwise, it's exactly the same type of material with the same problems in recycling, etc. This is an EVA that would use instead micronized fibers, a part of bio-based polymers and a part of like micronized straw as a filler to make. This is not used for cushioning applications, but mostly for semi-stiff applications like slippers or other types of object like boards, like these in the pictures. In this case, again, the company has measured the CO2 reduction by using this quota of bio-based materials, which is 23% compared with the virgin foams of fossil origin. They produce both, so they have made the an easy comparison between the two materials. Then we have biocomposites, because all the previous bioplastics would normally be compounded and also filled with fillers that can be bio-based or used as resins for biocomposites. By biocomposite, again, this is a very broad family of material, and we mean composite materials that is composed of two different components, one generally used as a binder and the other as a fibrous structural element, both with a biological basis. Wood plastic composites that are composite material, there is with let's say the matrix, which is a polymer, and the filler, which is wood flour. Usually per se they are not considered bioplastics unless the matrix is a biopolymer, but however they contribute to the reduction of the oil-based component in the material, and so they have a lower carbon footprint than similar material without the wood filling. On the other hand, there is a problem with recyclability, because of course, if you fill a plastic with some filler, then it would be much hardly recycled at the end of life. So that would make sense for very durable applications where the end of life would likely be incineration. Examples of this is a company that makes bio-based wood plastic composites, typically used for toys. This is not Lego, it's an imitation, and it's much bigger than Lego in terms of size. Normally, these companies provide several types of bio-based compounds using both biodegradable bioplastics like thermoplastic starch or PLA, and also non-biodegradable like green PE, as that we have seen before. These are all compounds for injection molding and extrusion. They would include wood fibers, a certain percentage of wood fibers, which can vary based on the type of application. Most of them are biodegradable. Some of them are compostable according to the European standard, and they are normally proposed for toys, furniture, and floorboards. This is another company that has created this biocompound. You may know it as just like a rice house. This is Italian. They have developed this project where they use coffee waste as a filler of PLA to make this biocompound cups. And they have now launched a broader family of composite materials, also with durable plastics like bio-PE, etc. So for more durable applications other than this one using PLA. In terms of composites, an interesting area is that of flax reinforced composites, or flax or hemp or other natural fibers that have very good performances in terms of mechanical resistance. If combined with either fully or partly bio-based resins, they would create composites that reinforced composites that would have a very high percentage of bio-based raw material, reducing significantly the carbon footprint. In some cases, flax also manages to be lighter than standard composite textiles like carbon fiber or glass fiber, and it has been already used quite broadly in automotive. We see here some examples of biocomposites used for the interiors of doors components, also because they would combine together correct mechanical performance, thermal insulation, and also some sound absorbing properties in one material. So instead of using several layers of plastic, these types of composites may help using one material solutions with various functions. So this is basically a combination of plastic and textiles. So we would go towards textile products. Bio-based textiles. Okay, so we have here again various types of bio-based textiles. The most common ones are natural fibers. There are plenty of them that can have animal origin or plant-based origin, like animal would be like wool or silk, and plant-based would be cotton, linen from flax, other fancy fibers, hemp, banana, kapok. There are many of them. Most of them would be cotton and linen. Then we would have man-made fibers, which would come basically from biopolymers, like, for instance, Sorona, which is a brand name for a bio-based polyester, or there are several companies offering bio-based nylon that would come from bio-based by 100% or partly bio-based polyamides, normally from castor oil. And then we would have all the family of cellulose-based man-made fibers that would be like viscose, modal, lyocell, rayon. These are all commercial names. The main difference between the viscose family and the lyocell family is the manufacturing process, whereas lyocell is less impacting because it uses enzymatic liquids instead of solvents. And then there is the family of biofabricated, that comes from bioprocesses, which is an area in evolution. There is actually nothing there that is, let's say, industrially available. An example is Spiber, which is so-called biosilk, artificial man-made silk. And there are also other companies that make something similar, but still that's something that's more like a future development. Okay, so some examples. Flax, as we've seen, is a sustainable bast fiber. It is an interesting material because unlike cotton, it needs much less watering and pesticides. It grows in Europe, so there are some companies that would also claim, let's say, small supply chain in terms of kilometer. It is very resistant. Clearly, the spinning and the creation of the fiber and then the yarn is a very complex process requiring a lot of water, which is, however, not contaminated. So it's just water that goes. So normally flax fiber manufacturing plants are close to rivers. So all in all, it's considered a material, a natural fiber that is more sustainable than cotton. a big part of the plant is converted into fiber, unlike cotton, where you have a small part that goes into the textile fiber, and most of it would be discarded. So it's an interesting, it is considered an interesting material. Other fancy materials, we have banana palm fibers. This clearly comes from in typical Indonesia, Malaysia, and other areas in Southeast of Asia, where banana is grown. In this case, we are talking about a fiber that is derived from a byproduct of cultivation that's focusing on the fruit. So it is also a way of reusing a waste that would be otherwise probably likely incinerated in situ. So farmers would just burn the leftovers there. With a, let's say, heavy polluting effect. So this is a way of retrieving that biomass and turn it into a durable application. When passing towards man-made fibers, as I was mentioning before, nylon can be bio-based, as just like polyamide can be bio-based. Normally it would come from castor oil. There are a few, let's say, suppliers of polyamides from castor oil in Europe, and they likely supply most of companies. These can be turned into polyamide 6 or polyamide 11. Both are quite expensive at the moment, but okay, let's hope that in the future the price would be low. The applications can also be in furniture. Another interesting way of considering the bio-based content is for finishing. Typically, to have a fireproof effect on fabrics, some let's say chemicals need to be added. In this case, the fireproofing is obtained with a bio-based process. It is basically a patented technology of molecular modification of cellulose, as a result of which the fabric in contact with fire carbonizes and it doesn't create the flame, retaining the oxygen and basically becoming self-extinguishing. So this is also an interesting perspective when it comes to bio-based textiles, because in this case, the company would use 100% bio-based yarns with a bio-based coatings and finishing, and I think, yes, it is also certified biodegradable. Then when it comes to filling and padding, kapok is also an interesting material. It is ultralight natural fiber. It can be used for padding of garments mostly, but the interesting thing is that it is derived from trees that need no watering nor pesticides. For some pillows, it can be used pure or in combination with other types of fibers. There are companies that offer blends of kapok and other either recycled feathers or recycled dawn, or other types of fibers, creating this blend, soft blend that can be used to filling pillows. And it is clearly not an alternative of polyurethane, because different type of performances, but for some types of application, it can partly replace some polyurethane. Finally, we have leather and leather alternatives. Leather, again, it is clearly another inherently bio-based material. It is a byproduct or a co-product, depending on the perspective of the food chain. These are intrinsically bio-based. However, all the necessary treatment processes make use of non-bio-based components, typically petrochemicals and heavy metals for the tanning process, which can have a significant impact. So there are some, we will see some examples of non-metal-based tanning processes, or other types of skins, I would say, that are not based on cattle, on cows, which retain intrinsically a very high carbon footprint, of which leather has a part. So if you can, the carbon footprint of leather is higher than a standard leatherette, a standard artificial leather replacement, because of the impact of the breeding the animal, which is it's not only on meat, it is also on leather. So when it comes to the process, there are several companies that offer plant-based tanning processes, which can be olive-based or other types of plant-based substances that would result in heavy metal-free leathers with, let's say, a slightly lower performance in terms of elasticity, for instance, in terms of resistance to stains, but still this company, for instance, has made like a brand out of their natural color. So they have created, how can I say, they have built upon this imperfection also of the tanning process, their brand identity. So that's also something interesting. Another opportunity is that of using fish skin. This is not very much, how can I say, applicable to furniture, although Campana Brothers made a very interesting design a few years ago using this pirarucu fish from Brazil to make a chair and a sofa. You may have seen it. And these scales are very big. Yes, this is a little bit enlarged, but they are very big. This is a very big fish. And again, it is a byproduct of local farming of fishes for food purposes. And the tanning process is much less impacting of that of cows. So, I mean, it's an interesting material. Then, as a final overview, we give you an overview of non-animal bio-based leather alternatives. Again, we have here a broad variety of materials going from synthetic suede, coated fabrics, sheets, biofabricated materials, natural sheets, and other technologies more fabric-like. So typically the synthetic suede are microfiber-based materials featuring a bio-based content like Curarai, Torai, Alcantara, cotton, for instance, and the top can have bio-based content, full or partly. Sheets are like extruded sheets instead, so it's like a sort of monomaterial. Biofabricated are materials instead obtained via biofabrication processes like fungi, mycelium, bacteria, cultured proteins is also an interesting perspective. Natural sheets are instead cuts from various plants, like wood, for instance. It can be worked to resemble leather properties, banana leaves, cork, etc. And then other technologies like materials based on other fibers or paper or other processes. I have made some examples here. And then for each of them. This is a partly bio-based suede-like fabric, as I said. Specifically, this picture refers to Toray Ultra Suede, but as I said, there are other companies that do it. It's like ultra microfiber. The texture is similar to that of a suede, and it has approximately 30% bio-based content. The origin is sugars, basically from molasses. So let's say byproducts of the sugarcane processing for the sugar industry. And polyurethane with partly bio-based content in the polyol fraction from castor oil. These are typically used in automotive, furniture, upholstery, clothing, footwear, everything. This behaves exactly like a standard fake suede. Then bio-based coated textiles. Typically, these are leatherettes, as I said, consisting of a bio-based, in this case, it's solvent-free TPU extrusion that's layered on a certified cotton base. In this case, the TPU is derived from non-GMO corn, from agricultural crops, not intended for human consumption. As I said before, most of them are not for human consumption. It's different types of corn. In this case, again, we will have a type of performance that is very similar to that of a standard coated textile. So the quality would be quite good. This is another example where the coating also incorporates some bio-based waste, in this case from byproducts of the industrial processing for other industry like cosmetics and medical. Of oranges and cacti, but there is also from wine pomace or from apples, or you may know those types of material from cactus, 100% cactus, agave, that there is a very broad variety. They are basically a fabric with a layer of either PVC or PU with a micronized content that would also provide some type of performance. Visually and also in practical terms, they are very similar to a standard coated textile. So fully oil-based coated textile. So this is an interesting type of easily available material. Then we move towards more, let's say, experimental materials. This is a fruit-based sheet that's made out of fruit wastes, mixed and ground into fine pieces, and with a biopolymer compound, which is, let's say, proprietary recipe of the company. It is used as a binder, the quantity varying from 60 to 80%, which means that the rest is fruit. It is available in 2 versions. The company originally made the sheet and then made also a coated version, is now proposing that. The dyes, the colors are natural colors that are certified Ecotex. The material can be cut and worked like any other types of similar solution. Can be laser cut, printed, embroidered, woven. Also, yeah, you can see some examples on top left with nice patterns that can be laser cut on the surface. Then there is all the family of mycelium-based leathers. This was or is, no one knows, a very promising area. Milo, which is the company that used the technology from Ecovative or Ecovative, I don't know how the correct pronunciation, and which was the most advanced in this area. They had made several capsule collection, etc. They announced this April that they would stop the production, which, yeah, leaves open to other players that indeed exist. But still, this is, let's say, a complex type of material because it grows literally. So it cannot be made yet in a continuous process. So it is, let's say, complex to scale up into in an industrial environment. Okay, this I forgot the image, apologies. Materials from bacterial cellulose. I'm sure that it was there for some reason. I don't know why it's not there anymore. Anyway, it was a material that made from bacterial cellulose. There is a structure of a woven structure, leaving some holes, and the bacterial cellulose, again, is layered and then dried. The result at the moment is still papery a little bit. It is used, again, only for leatherware, like bags and that type of things. But this is also an interesting perspective for the future, potentially with also applications in other more demanding industries. Then we have flexible sheets from wood and cotton. This is a very thin layer of wood that is lasered in order to obtain the necessary flexibility, and which is doubled with the cotton. Also, in this case, we have 90% minimum bio-based content. Also, the binder could be bio-based. It's yeah, a material that is an alternative to leather. It has nothing to do with leather, clearly, because it has different performances, different look and feel, but it is an example of those sheets that I was mentioning in the scheme. And I think this is the last. We have this other material, which is under the family of other technologies, because this is more a textile, but the function is as a leather replacement. It is made of pineapple leaf fiber. You may know it, it's Piñatex, super famous. It has been famous for, but then it has like some stiffness, which makes it closer to non-wovens rather than to leathers. It is a sustainable alternative to leather and petroleum-based textiles. I realize now that before I was talking about banana, while instead of it's pineapple, not banana. As I said before, for the yarn that comes from the same company, it is a byproduct of the agriculture industry, so no extra land, water, or pesticides are required to produce the raw material because it comes from waste. So all the waste, the agricultural waste perspective is where everyone is looking at to develop new materials. The material is biodegradable, water resistance, and formaldehyde free. And the binder is a blend of PLA and also other types of binders. And that's it. If you, it's 11:05, but if you have some time for questions, I'm available.
Thank you, Anna. I ask the attendees if they have some questions to write in the chat, or if they want to participate directly. I ask you, first of all, a first question in terms of duration of these materials for the deteriorations, if there are some limitation comparative in comparison with other traditional materials.
That would depend on the material. Normally they may have, particularly these last, let's say, more experimental materials, for sure they may have problems. Normally, companies would provide, the first thing that a company providing either fancy materials or bio-based alternatives is giving a technical sheet. So telling, I don't know, abrasion tests or concerning abrasion resistance, as resistance to traction, planarity, especially when we talk about, let's say, new binders for chipboard, for instance. They may not provide the same level of flatness, okay, which of course it is extremely important. So yeah, clearly bio-based, there is a tension always between being degradable, so coming back to nature, and being resistant, right? So clearly it's always a matter of finding the right balance based on your application. If you make clearly, if you make something that needs to be durable, there are a lot of bio-based materials that are durable. Wood in the first place, right? And then the idea is to finish wood with materials that are also somewhat bio-based, and trying to avoid soaking wood or wood-based materials into oil-based finishings. Otherwise, it really doesn't make sense.
Perfect, thank you. So there is Federica Ariaudo, yes, that remembers you, that she waits for your answer.
On the ASTM test?
Yeah, the answer that she
I don't have
before.
that answer now. What I can do is making a small research and then answering to Federica later.
Perfect. And there is a question from Gianfranco Del Longo. Have you seen the chat?
Different compared to synthetic ones in terms of VOC emissions? Yeah, no, yeah. Again, they are often tested on this aspect, because yes, normally they have lower VOC emissions. Clearly, again, that would depend on the family of materials. Normally, for instance, coatings which belong to the family of biopolymers in a way have lower VOCs. And since this is a important marketing claim, companies would test them for that and provide also tests to compare to substantiate their claims. When it comes to wood is, I mean, intrinsically emitting formaldehyde. So what what happens is finding solutions that would not add further formaldehyde, especially for wood-based materials. And I would say that most chipboard companies are currently developing bio-based binders exactly for that reason. The challenge, again, is having the same type of performance in terms of flatness and homogeneity of the surface. But I know some companies have already introduced that type of chipboard with bio-based binders. Others are working on that, both chipboard and MDF.